So today we will start with making defensive recommendation from the attack map data like threat intel we extracted in earlier classes, TTPs. So we will see after extracting TTPs from the threat, either from threat reports or raw data, how one can leverage that to make a defensive recommendation for the client. So for applying threat intel to a defense, till now we have seen few ways like extracting threat intel from finished threat reports, from raw or incident data. Also we studied about how we can leverage and analyze the extracted threat intel data with the attack navigator tool. Again, we can identify the techniques used by multiple groups using those analysis, and mostly the threat groups which are more threat for our specific organization. So usually threat groups works based on their motives. So some threat groups more targeted towards the financial organization, some are more towards the critical infrastructures. Even in the critical infrastructure there are power plant, nuclear plants, so there are various groups who more focus towards the water treatment plant, like that. So based on that, client or analyst can set their priority from where to start from the all extracted threat intel data. So once we have a list of TTPs or a list of attack patterns which has been seen in past attacks, how we can make that actionable, how we can implement those threat intel data in a real world to make a defensive recommendation or implementing countermeasures or mitigation steps. So as usual, like we saw in mapping TTPs from threat report or raw data, for making a defensive recommendation there are various steps which we usually follow, which starts with determining priority technique. Out of all extracted TTPs, all are not equal. Some TTPs might be more dangerous, like the TTP which is related to credential access is more crucial than, I should not say, but in some specific case it can be for any defense evasion methods. So something like that, there will be a priority between all set of TTPs which we extracted from the attack incidents. So once we have a list of TTPs, we will prioritize which one to look first. Once we prioritize the TTPs or threat intel, then further we have to research how those techniques has been used in the victim infrastructure. So that will give us a contextual information like what has been attacked actually, and whatever has been attacked or what has been compromised, how we can add or recommend a mitigation or a countermeasure steps on that. Once we understand how technique has been employed in the victim infrastructure, then we analysts research about defensive options related to the technique. So once we understand where it has been actually implemented, how it has been actually implemented, analysts have to research about what all possible defensive options we have for that special case. Once we are done with it, analyst has to research organizational capability and constraint. Let's say we found some set of defensive options which we can implement to restrict those TTPs to get executed in the environment, but after that we need to take care and keep in mind the organization capability, like what capability our organization have and what all constraint we have. Based on that only we can implement countermeasures or mitigations, or even we can recommend a client to implement some countermeasures or mitigation. Once we understand the organization capability and constraint, we have to determine what trade-offs are for the organization on the specific options. So the all defensive options we had, and once we neglect defensive options based on the organization capability and constraint, we have to see what all the pros and cons can be of those recommendation or the mitigation which we are going to suggest our client. Once we understand the trade-offs, then we can make a final recommendation. So there are multiple ways to prioritize the extracted TTPs or the attack patterns, but today we will more focus towards the threat intel based. There are 4 ways we will be discussing. First one is data sources, in which we can see what all data sources we have already from where we can get the intelligence. The second one is threat intel, where we can see what our adversary is doing in that in that environment. Then third one is tools, where we can see that what can your current tool covers, Like the victims has whatever tools and implementations we have, what exactly we are covering and where we are lacking. And the fourth one is red teaming, where we can see that what the client or victims red teamers are doing. What exactly how they are testing their environment and what exactly they are doing and where they are lacking. So in this way we can understand the current state and determine which techniques we should prioritize over the current state of the victim infrastructure. If you remember in the last class of APT 39 and Ocean Lotus analysis of TTPs between APT 39 and Ocean Lotus, we found this set of TTPs as overlapping TTPs. So we will consider or we will assume that our victim organization has significant threat from Ocean Lotus and APT 39 groups. So we will focus on set of techniques which has been used by both of the groups. So if you remember, these all the 7 techniques we had in our attack navigator we saw. First one is spear phishing attachment, other one is link, the third one is scheduling task, scripting, user execution, change in registry, run queue, startup folder and network service scanning. These all were the overlapping techniques. So first of all, these all 7 should be more prioritized over other techniques which APT 39 and Ocean Lotus are using individually. So in this presentation we will start with the user execution and we will focus on this, but the way we will recommend defensive recommendation, we have to implement the same for all techniques on which we are working on. So once we fix the techniques, which one to prioritize, from which one to start with, we will research how techniques are being used in the victim infrastructure. So as we had threat report in our case study in the last class, we will see those threat reports for APT 39 reports and Cobalt Kitty and see how they are explaining that this is, user execution is being done. So this APT 39 report, what we saw that this group is leveraging spear phishing emails with malicious attachment and or hyperlink, typically resulting in a forward infection. So we can understand that there is a spear phishing email is coming to the victim, which is victim is clicking on that link or the attachment, which is making this user execution techniques, to execute. In the Cobalt Kitty report, we saw that the 2 types of payloads were found in the spear phishing email. Again, there is a spear phishing email which has been executed by the victim, which leads to user execution. So we have to, once we understand, now we will see this user execution MITRE ATT&CK knowledge base. Like it will give us an idea that how it is being used all over the world. So this was for the specific or our case which we are investigating. And this one, this MITRE ATT&CK knowledge base will consist all over the knowledge base which has been seen till yet how attackers have used user execution in past attack campaigns. So if you see few of the examples, you can see most of them, even though all of them are related somehow either the spear phishing email or the attachment or the link. Okay? So we can have an idea that even once this user execution techniques triggered or we found in the victim environment, there is a chances that there must be some spear phishing email has been dropped to the victim on which they have clicked, either its attachment or link. Once we understand about how TTPs or how attack pattern were being used in the victim infrastructure, we have to see what all defense options we have for that specific technique. To get the defensive option, we have a various way to look into it. First one is attack knowledge base. So in the attack knowledge base, if you see any technique webpage, there will be one section for data sources, which tells from where this techniques has been collected or has been seen in the victim infrastructure. Then detection, what all detection methods one can implement to detect these techniques. Mitigation, which will tell what all countermeasures we can implement to mitigate those technique in the victim infrastructure. Then also there is a research link to the technique page. Like once you open any technique page, which we will be seeing in the next slide, there are many references which links when this techniques has been used in the past attacks in the references section on the downside of that technique page. After that, we also have MITRE cyber analytic reports, a repository which is in short we say CAP. This gives a structured way to analysis of the past attack and which can be directly ingested and communicated with using SIM tool. Also, there is a researcher Roberto who has released many threat hunter playbook which lists defensive options for the MITRE attack TTPs. Further, we also have atomic threat coverage even given by and presented by MITRE only, which covers the all atomic TTPs or the threats and how one can implement a defensive mechanism to deal with those TTPs. Further, you have to supplement with your own research. So, along with that we have to see multiple various options. There are various options in the open domain. So, one need to do their own research also rather than only relying on these things. So, we will see a technique pairs this user execution. Here once you open any attack TTP or technique page, you can see here there is a section data sources where there is a places and resources mentioned from where evidence and the behavior has been seen for this specific techniques. So, you can see for user execution antivirus which will be obvious, then process command line parameter like what all parameters is being given to the command line, and then process monitoring. Further, in the downside of the same page you will be seeing a mitigation section where there are various techniques or methods has been listed which can be used to mitigate such TTPs to happen in the victim machine, such as execution prevention, network intrusion prevention, restrict web based contents and the user training. So, this spear phishing case user training is much more required to mitigate the any such phishing to get invaded by any phishing emails. Also in the same page you can see a detection section where several ways has been discussed how one can detect execution of such TTPs. So, the first one is to monitor the execution and the command line argument for every application. The other one can be antivirus and the third one can be endpoint sensing tools. Also, this is the set of references I was talking about. So, there are various threat link in the reference section which lists that this TTP has been used in the past attack and how and when. So, one can refer these things to do their own research. Also, we have a Markeology where this website provides the MITRE attack logging cheat sheet for Windows machine in which they have linked each TTPs, MITRE TTPs to the Windows event IDs. So, even after seeing the Windows event IDs, you can suspect or even you can map the TTPs based on the ID number, such as you can see that this Windows event 4688 having you can see first the process command line and the process execution having this TTP user execution inside the execution tactic. So, whatever defensive options we discussed just now has been listed here for the reference. One can go and search here to understand the defensive options for the TTPs. All these references are aligned with the MITRE attack matrix. So, all these defensive options are aligned with the TTPs which are listed in MITRE attack framework. Okay. So, for our case which we started with user execution, once we understand and we go to all the defensive options which we just saw, we listed out this set of defensive options we can implement. So, first one is user training which is obvious for the spear phishing and the user execution case. Then application whitelisting, what needs to get executed will restrict the domain of that. So, only the whitelisted applications should be executed in the victim environment. Then blocking unknown files in the transit. If there is unknown files is being in transit in the network communication, one can block that. Implementing NIPS, network intrusion prevention system, file detonation system. If any suspicious file comes to the victim machine, that needs to get analyzed first in the sandbox environment. Then monitor command line arguments like we can see Windows event log and this Sysmon. Sysmon is used to monitoring the Windows events. It is an open source Microsoft tool. One can explore this to see how events is being generated in the Windows machine. Implementation of antivirus and the endpoint sensing machines. Once we make a list of defensive options what we can implement, now we have to see the organizational capability and the constraint. In this capability and constraint section, we have to look what data sources we have, what defense mitigation we already placed in our environment. So, based on that we need to see what all options we have and how we can possibly we can see a new analytics on the existing sources rather than implementing a new tool, or if we can leverage the existing employed tools and the defenses placed on the victim organization. So, whether we can leverage that or not, we can have an understanding after listing all these things. Then we can see what products are already deployed that may add capabilities in the victim infrastructure, like whether we will be able to gather new data sources or implement any new mitigation in the current scenario only. Also, is there anything about the organization that may preclude responses such as user constraints and user usage patterns? So, here the list of notional capability and constraint we listed. For the R case, this is just an assumption that Windows events are already collected to this SIM, but not the process info. We are already evaluating application whitelisting tool. We have a highly technical workforce, already having an email file detonation appliance, already have an antivirus on all endpoint employed on the victim infrastructure. Then the constraint of the victim infrastructure is SIM at a close to the license limit, which is obvious because mostly SIMs are proprietary, and they may increase, and that can be more prohibitive to make any changes and make a customizing that based on the requirement on the recommendation which we are going to propose. There can be large portion of user population developer, and running arbitrary binaries may be as a requirement for the victim infrastructure. So, that can be a constraint, so that we need to give recommendation based on that this arbitrary running arbitrary binaries should not be stopped. Also, files in the transit usually encrypted passing by NIPS. So, if this file which is being transited in NIPS, that can, if it is usually encrypted, so that may increase less visibility about the file content while performing this analysis. Now, once we understand the constraint and capabilities of the victim infrastructure, we have to see what all trade-offs there are for organization on this specific case. How do we each of the identified option can fit in our organization? This is the main objective to seeing this trade-off. So, we can see that if they are leveraging existing strength tool data sources, can we do that? That can comes under the pros. And also we can see that if we can use any existing strength tools or data sources to implement the defensive mechanism or the recommendation. And the cons can be that we might be recommending something which is not much cost effective, and also there can be a poor culture fit with the organization which is required to do that user training for the phishing kind of attack. So, this is highly dependent on our specific organization case. So, in our analysis, what we come to we listed defensive options what we made, their pros and cons as a trade-off. Based on that we can understand out of this what all things we can propose as a recommendation. So, as a defensive options, first one is increasing user training around the clicking on attachments or the link. So, as a pros, this covers the most use cases, and even the technical workflows will likely to make a good sense for the organization. But the cons can be timely investment of the users and training fatigue of security. So, user might not be get under the news training which tells them and train them about this clicking on the unknown emails, link or attachment. The second defensive option is enforcement of application whitelisting. So, these pros and cons we have to brainstorm that once we implement and given this defensive options, what all the pros and cons can be in the future for the organization. So, the second one is enforcement of application whitelisting. So, we talked about whitelisting the applications. So, this can be already examining, like we saw in the capability that we are already examining the whitelisting solutions. But again, most binaries of the concern never seen before, like there may be a binaries which has to be, like there may be a system in the victim infrastructure where has to be kind of regularly, they have to run arbitrary binaries for an experimental purpose or research purpose, and that comes under the cons. So, in that case developer population will be highly impacted if we implemented whitelisting applications. Monitoring command line arguments and create analytics. which leads to pros related to collecting events. Already, like we saw that they have an event which is collecting using Steam, and then the as a cons that can be, if we are this Steam was not collecting the process information, but we implemented that collect each and every specific detail, then that may create more volume in logs, and which can be also the likely can be unacceptable license cost which organization has to bear to implement such a heavy like collecting all specific and to the point information. Implementation of antivirus which was already in the place, and also the antivirus may have as a con that they may have a limited signature coverage. Mostly antivirus works on signature matching. Even these days, the installation of endpoint detection and response EDR products. So, one can recommend to install a EDR product which can detect and give a response for each and every employed in the victim infrastructure. So, this can give possibly a best visibility without greatly increasing the log volumes, but as we saw there is no existing tool, and this can be even like kind of much expensive if the victim infrastructure is a small business. Also, we can recommend to email detonation appliance in which email should be get analyzed in a sandbox environment before delivering or before using on the user interface, and we saw that that is already in the place, but again the email were encrypted in the transit, and that may not give a full visibility for the all incoming packets to the network, like because they are going to get first into executing and the for checking purpose in the sandbox environment, then only get delivered on the user email box. Now, based on our analysis, our the assumptions, we have to make the recommendation. But while making a recommendation, we talked only about the technical things, but that should not be only technical recommendation. That can be related to technique, policy or risk acceptance. In the risk acceptance, one can accept the risk if that is bearable for the victim organization. Also, this recommendation could be for management team, could be for security operations center, could be for IT, and even all of the above. So, some of the potential recommendation types are inside technical, policy and accept risk. For technical, we may have to create or collect new data sources from the victim infrastructure. The other can be writing more generalized or more coverage detection and analytics from the existing data. One can recommend about the changes in configuration or implementing some new engineering methods to detect or make a defensive to employ the defenses on the victim infrastructure, and one can recommend to purchase or get the new tool like EDR we saw in our defensive options. Once we done with the technical recommendation, policy related recommendation can be such as we saw that user training that which can be human related or the technical related. The third one is accept risk, in which some things can be undetectable or unmitigable. That totally depends on the victim and the kind of threat we are analyzing. So, based on that, and even if that is not worth to trade off, one can let it go and accept risk related to that that possible threat. So, this is claims of the APT39 and OCL Lotus TTPs which we made. The green one represents the high confidence in detection. The yellow one represents the low confidence in the detection of the TTPs. The white one represents no confidence, and this deep yellow one represents prioritized technique. Like out of these techniques, which techniques we have already prioritized and made the defensive recommendation. Now, in the finally, we concluded with the three kind of recommendation. The first one is that user trainings needs to get placed to get the users aware about the malicious emails or mal spam, and there should be policy change to match the technical workforce to deliver such kind of such kinds of user training for the all employees present in the victim infrastructure. There should be continuation of using antivirus, which is not even adding any additional cost, and then the third one is increasing coverage of email detonation. So, we can as we had already detonation system, when one can take advantage of that existing tool to increase the coverage. Now, it is a homework that there is a worksheet present here on this link under exercise 5. You have to go through this making defensive recommendation guided exercise, and you have to download the required the details, and you have to do all this analysis practice by yourself to make a defensive recommendation for the given organization. So, as we discussed, you have to follow all the steps like determining, first of all you have to determine priority technique, then research how this technique is being used, then what all defensive options we have related to that technique, what all the organizational capability and constraint we have, and we have to determine the trade-offs for this specific organization given to you, and then the making a recommendation. So, while going over this exercise, you will be seeing that you have to see that what resources were helpful for you to finding the defensive options. So, this is the crucial, even start with the recommendation, what all defensive options and how we can get the knowledge about that. So, you have to see that what all resources you can get, plus what kind of recommendation you are ended up by making, what all kind of recommendation you are finalized with. Do you consider done to doing nothing or accepting the risk? Is there any techniques for which you accepted that okay, I am not going to implement anything for this, let's accept the risk related to the threat, related to that TTP or that technique, attack pattern. Were there any options that were completely inappropriate for you? So, was there any option which were not aligning with any of defensive options which we saw? So, in the given exercise, again we have this set of TTPs, and we will go with the scheduled task techniques and see how we can make a defensive recommendation for this technique. So, in the report, if you see there is scheduling task, the scheduling task is being performed using this command. In the COBOL kitty report, it is like they are using SCH task command, and here in the there was a file document which were delivered using the spear phishing email. In that macro section there is something which is, there is some JavaScript code which is scheduling task. Again we will go through the technique web page, we will see the all data sources we have, like file monitor, all data sources what we can look for to see this behavior related to this TTP, like file monitoring, process command line parameters, and the Windows event logs. In the detection section, we can see that on the same page there will be detection section where you can see that monitoring scheduled task creation from common utilities like command line invocation. You can see configuring event logging for scheduling task creation. You can see that how events is being logged in the Windows task scheduler and operational. So, you can see all these event IDs with the corresponding details. One can also use tools like sysinternal autoruns, which is a Microsoft open source tool which can help you to see, which can be used to detect the system changes, and also it helps to understand the persistence like listing current scheduling task, which give us a idea what all task has been scheduled in the environment. Also one can monitor processes and command line arguments for seeing the scheduled task. For this exercise, this organizational capability and constraint, you have to assume that we have already Windows event log collection which is going to be SIEM tool, then but we do not have ability to collect the process execution logging, but this scheduling task is more related to the process execution. So, one has to give the defensive recommendation based on that. As a trade off, we will see what all defensive, we will list out some set of defensive options, their pros and cons. We will go with that monitoring scheduling task. I will go a little bit quickly with these things because we already did for user execution. So, we gave a defensive recommendation that monitoring scheduling task by creating common utilities which we saw in the detection section, which would allow us to collect the detailed information about the task, how it is being added, but the organization has no ability to collect the process execution logging. So, how one can understand that which process is being scheduled. The next defensive recommendation is configure event logging for scheduling task creation and changes. So, which fits well into the existing Windows event log system and would be simple to implement the enterprise wide. But again this increased the logs volume. Then the third options we saw, that sysinternal autoruns which can be used and would allow to collect the other persistent techniques as well along with the scheduling the task. And as this tool is open source, so that is pro, but as a cons that there is no correctly installed such tool in the environment. and would need to be added to all system along with the data collection for analytics purpose. The last one is monitoring processes and command line arguments, which we saw in detection option. It would allow us to collect the detailed information about the task scheduling, but again this organization has no process execution logging capability. So, we will make a recommendation based on that given the limitation and sources we discussed just now, that one need to enable this task scheduling option in the window machine for logging service and create analytics related to the event IDs mentioned on the detection section of the technique, and possibly one can use this auto run to see the changes as it is an open source. So, this is the all we have for the making the defensive recommendation. Now, we will see a case study where I will be showing you a totally clear picture what is expected from the homework 2 and how you are supposed to follow. Okay. So, there is a case study, it is a piece of threat report, 2-3 pages of the threat report, which similar to as I shared in the homework. So, you are supposed to, as we already mentioned this in the homework, that you have to go through the report, understand the attack patterns, map the corresponding TTPs, use navigator to map those TTPs, use their comment section to give a contextual information, and once you have done with the TTPs, you have to see defensive recommendation, and before that you have to make an assumption. Here we were making assumption related to the organization and their constraint. So, you have to make assumption like for all of your specific case for each group, and then you have to do this trade off thing and go with some defensive recommendation option. So, I will show you the reports. This is attack of ByteRapidity, which is from South Asia. Mostly this group mostly target Pakistani and Chinese government organization. So, we will see a glimpse of this threat report and how we are going to map and how we are going to make a defensive recommendation for this case. Okay. So, this is annotated glimpse of that report which I just show you, that there is a spear phishing email as we can see here. So, we mapped it as initial access and phishing attachment with their corresponding ID. There is that email is masquerading as a legitimate email. So, we mapped it as a defensive agent and masquerade. This is all you have to do in a homework too. So, I am just demonstrating you to make you clear and make it easy for you to do the assignment and understand even the assignment, and for even this will be helpful for your exam. So, masquerading which comes to defensive agent tactics, and the techniques is masquerading T1036. Further, that email contains a maldoc, which is an RTF document, and the micro Excel spreadsheet. Again, this is supposed to be executed by the user. So, we mapped it as execution, and execution tactic and technique is user execution. Even inside the user execution, there can be files or links which user has executed. So, there is a sub technique named as malicious file having ID T1204.002. Further, if you go down, we can see the techniques that the actor has spoofed the sender's email. The email which was showing in the sender, that was a spoofing email. So, here one can use that, there can be a forging of web credentials of using someone else's email to send the email. Then there is the actor exploited the possible vulnerability in Zimbra mail server. So, this comes to the technique related to the exploitation for client execution. Then further, there is a execution where the RTF documents has been executed to get the embedded code or the object. So, this again comes under the user execution, and which is launching to scheduling a task. So, it will go to that scheduling task technique, and which is which is configuring two scheduled tasks. One of the scheduled tasks downloads Trojan from here. So, we can see that there is something is being downloading from the CNC server. So, in the last class we saw that there is a technique for that, ingress tool transfer. You can see, you can understand all these things from this diagram also. Then payload runs as a Windows security update service. The payload, the malicious payload is trying to look like legitimate with the name of this update service, Windows update service. So this comes to technique related to masquerading task or services. It is masquerading to legitimate service. Then they are establishing communication with the C2 and remotely downloading the executable file. Again, this is CNC communication application level protocol they are using, and the system service execution they are executing. I'll go a bit slow. I'll not go for the whole report, just to show you. In similar way, you have to download or you have to understand the behavior and the attack patterns and map the corresponding TTPs in the given report. Is it clear? Once you are done with the also there will be some assembly language code like reverse engineering of the executable payload. You may find something related to the TTPs here also. So keep eye on your images, on the text and everywhere. Now I'll show you the report. No, before going to the report, I'll show you the assumption what we made. Okay. So here we made an assumption that this RAB is an anti-crime, or this report was published by them. So being at the forefront of the national crime detection, including both cyber and physical, we expect like we are masquerading that organization as like we are related to that organization as we are analyzing these attacks. So we are making that, we are expecting that we have a SOC employed at the victim infrastructure. However, this persistent attack by the byte group, we can still see a scope of improvement. You can assume that. Then there can be an absence of email spoofing detection software. There can be absence of email detonation software. Also, there may be as there were data exfiltration happen. So I may assume that there is no sensitive information was lost, indicating that there is either sensitive documents are stored there or not. So similar, you can make an assumption. So this is kind of very little small assumption you can make based on the whole report. This is just a kind of demo I created for you. Okay. After that, we can go with the defensive recommendation what we listed out after going the all techniques web pages, seeing the detection and the all defensive options. First, peer phishing. We have listed that antivirus or anti-malware software should be implemented, NIPS machines, NIPS system should be implemented, there should be user training, there should be software to detect spoofing, and there should be email detonation softwares. For exploitation for client execution, there should be monitoring the abnormal processes, security patches should be installed immediately to disable vulnerability. For window command cell, we can see that the execution prevention can be implemented or even command execution detection can be implemented. For a scheduling task should not run the system permission, that it should not get the root privilege of any scheduled task, then the priority should be given only to the admin to schedule the task. System services, one can prevent the users from installing their own launch daemons on their machine. Also, one can disable higher permission services execution by the users. Users should have a limited permission to execute the executables in the environment. Malicious file execution, again there is a need of user training and antivirus. Also, we can monitor for file or process creation by using the sysmon. There is one more abuse elevation control. Further that, then we have a masquerading where one can say that there should be assigned binary required for any execution, and user training which is obviously required to understand what emails are masqueraded or they masquerade some legitimate organization or what. Then there should be forged web credential where one need to understand that there should be a user training place to look the header information of the emails before clicking on any attachment and the link. So there is a concept of analyzing the headers, email headers. So by analyzing you can understand that the shown email is from is the real or the spoofed one by tracing out from where it comes from. Then there is a query registry in which creating logs to detect the API calls for process discovery. Query registry might given a pattern for adversary behavior. So how they access the registry, there can be a pattern for any adversary behavior, like to to change, to get the persistence, how attackers changes the registry, what is the exactly pattern. One can do analysis on this. The next is software discovery, where logs must be maintained for each API calls and see if there any discovery is being performed in the environment. There can be this C2 communication which can be tracked by intrusion detection system and prevention system. Then there should be a encrypted channel, there was a technique, encrypted channel and web services. So one can use proxy server to understand the traffic flows and immediately block any suspicious incoming or outgoing traffic. Ingress tool transfer, in which we can monitor the file creation and file downloads, what file exactly is being downloaded on the machine and what all the files is being created on the system and how it is being created. Again, exfiltration over C2 channel, exfiltration happen in that attack. So one can use the automatic authentication for any file upload. So usually this exfiltration happens by uploading the victim data on the C2 server. So there should be an authentication mechanism implemented before uploading or before sending any file by any process in the victim infrastructure. Also there should be a user training which is obviously required for any cyber security threat. So these are all the list of defensive recommendation and more like technical defensive recommendation. Then few of them have, there is a pros and cons for those defensive recommendation which we just saw. Like for antivirus, one can implement that often the first line of defense already in place detects and stops lot of commonly used malwares. As a cons, one can say that there will be limited signature coverage. There are very few antivirus who really focus on the behavioral aspect of the system, rather than these antivirus are more dependent on the signature matching. And also this antivirus needs to be updated all the time. And for even the small organization, that can be a kind of not much cost effective, which will vary based on the organization's capability. NIDS, NIPS, which we recommended, this will be very much useful to analyzing the web traffic and making the jobs of detection and prevention easier, rather than on the other hand, the latency of the server may increase a bit and encrypted files may fool the system. So mostly the APT attacks, they encrypt the communication between the C2 server and the victim machine. So in that case, understanding the encrypted network traffic and analyzing them a little bit difficult for the NIDS or NIPS. But there are some research which has been done to even understand the encrypted traffics to some extent. Then we recommended it about user training and awareness. This can be essential to improve the cyber hygiene of the company or the organization, and which is usually can be a most attack vector like human. Mostly attackers targeted human before the victim organization. Also this can be a kind of time consuming and again fatigue, which we discuss. There can be some software implementation for anti-spoofing or detonation, and as we assume that we already have it in place and which comes with the package of the Microsoft, and again this detonation and the softwares implemented here can be very limited and specific to the purpose for which we have implemented. There can be a logging mechanism like capturing Windows events using Sysmon. We suggested in our defensive recommendation, and we assumed in our assumption that it is already in the place, and but this can be the analyzing the Sysmon events a kind of little bit manually extensive with the perspective of labor cost, because there needs to be a skilled worker to understand each and every event IDs, what they represent and how they are correlated. Finding the correlation between the multiple events captured in the Sysmon is quite expensive. Then there can be heavy volumes of logs obviously. Then policy config setting, this can help us to low cost upgrades, and open source, one can use the open source tools to minimize the cost. Also this policy config setting is a periodic activity and needs to be done on the repetitive basis. Then there can be security config, network segmentation proxy, and one can establish a IT security department. One can suggest to establish a specific targeted security department which should look over out of all security aspects of the organization. So this may require a dedicated team, and which can be kind of labor cost and require a lot of time and need professionals. But on the other hand, if we do that, there can be a dedicated team which having like required skills, and they can implement the structured process for automation and may implement the countermeasures before any threat is getting exploited. So these are the recommendations, their pros and cons we discussed. Now I will just show you the attack matrix which we created for this attack. This is the Excel, we exported the attack navigator map TT page in the Excel format. This is the Excel glimpse of that. So we saw that we had phishing, command and scripting interpreter, exploitation for client execution, scheduling tasks, system services, user execution and other techniques. So you are also expected to either download the attack navigator map TT page in this format, or see you can see or in the JSON format. Also you can see that here we have added a context on the user execution. Once I hover the mouse here, on opening the RTF document, the execution editor is executed automatically. Then for the system services, that how it is being used, from scheduling task, how it is being used. So similar ways you are expected to do your given assignment. Then I'll just go quickly with the recommendation. I guess time is over now. So the same defensive recommendation which we discussed, you have to list and discuss about that technical aspects and the policy aspect and the risk management. Is there any threat which you are going to accept in your case? And if you are accepting any such threats, give a potential loss, what can be if you are accepting those risks, and give a like kind of fruitful reasoning behind that why we are accepting such risk. Okay? This is the all is expected from the homework to assignment. So you have to start from analyzing the attack from the threat reports till you have to go making a defensive recommendation. So you have to assume that you are a threat analyst. You have given a client infrastructure and you have to understand client infrastructure, understand the attacks, how attacks flow, what all attack patterns has been seen in the attack. You have to understand what all the recommendation we can make for the client to implement for the purpose of implementing countermeasure or mitigation. Is it clear? Did you understand the end-to-end work which you are supposed to do or supposed to practice with the help of this homework too? Any doubt? Yes. I can if it is required. Sure. So this will give you understanding how we understand all these things step by step, like first we understand how to understand the attack pattern, then how to analyze that, then how to make a recommendation. You have to club all these things together and do the homework too. Okay? So we'll wrap up now. Thank you for your time.